Okay, so we are going to do the last lesson in Module 15, 15.4, Segment Relationships and Circles. So on page 816, we are going to be talking about the first thing is the chord-chord product theorem. Now, the chord-chord product theorem says that if you have two intersecting chords, there is a relationship between the lengths. Previously, we were talking about the arc measures. Now we're going to be talking about the lengths of each of these chords. When they intersect each other, the relationship is this part times this part equals this part times this part. And that's it. So let's use it. Setting up the chord-chord product theorem, we are going to say that x times 3 equals 6 times 2. 3x equals 12, therefore x is equal to 4. And that's it, simply. It says find the length of each chord. We could say that CD is 6 plus 2. So CD equals 8. And then we could say that AB is 4 plus 3. So that's 7. So those are going to be the lengths of each of our chords. We'll do one more example of this type of problem. 6 times x equals 9 times 8. So 6x equals 72. And 72 divided by 6 is 12. So x is 12. We want to find each of the chords. So 6 plus 12, ki is 18. And then 9 plus 8 for hj is 17. All right, so I'm going to give you two problems that you could do on your own here, or just one, kidding. I'm going to go ahead and pause right now, or why don't you pause the video so that you can have a chance to do this problem. Through the power of editing, ta-da. 14 times x equals 3 times what? Well, it says that AD is 12. So if AD is 12, then 3 minus whatever, that must be 9. So 14x equals 3 times 9. The next theorem we're going to do is the secant-secant product theorem. Well, if you have a secant and another secant intersecting our circle, the secant-secant product theorem says the entire thing times the outside is equal to the entire thing times the outside. Kind of like the chord-chord product theorem, the way that it's structured, except for we're not dealing with two intersecting chords this time. Once again, that is the entire thing times the outside equals the entire thing times the outside. So let's go ahead and use that one. We want to solve for x. I think that's what we want to do. We want to solve for x, and we want to find each length. So the entire thing. So that's going to be 5 plus x times the outside, which is 5. And I like to put my outside on the outside of the parentheses. Equals the entire thing, which is 6 plus 6, which is 12, times the outside, which is 6. So we'll distribute our 5. So we get 25 plus 5x equals 6 times 12 is 72. We're going to subtract 25 on both sides. So 72 minus 25, 47, and then we'll divide by 5. So we get x equals 9.4. Let's find the length. We just take 9.4 and we'll add 5 to it. So we'll get AC is 14.4. BC is 9.4. AE is 12, and DE is 6. Let's go ahead and do it again. we've got the entire thing times the outside, entire thing times the outside. So we'll say the entire thing for the first one is 14, the outside is 6, and our outside for this one is 7, and then our entire thing is 7 plus x. So we'll multiply 6 times 14, which gives us 84. And then we'll distribute our 7, so we end up getting 49 plus 7x. 84 minus 49 is 35. So x is equal to 5. Let's go ahead and plug that in. So we have SP is 14, UP is 5 plus 7, which is 12. And we could say UT is 5. All right, so why don't you go ahead and pause it so that you get a chance to do these two problems. And we are back. So the first one I set up where the entire thing times the outside, and the entire thing, so the entire thing times the outside, multiply, distribute, solve for x. The same thing for number 7. I'm just kind of going fast because I know that we have one more section to go. So the last one is the secant tangent product theorem. It says that we can take the entire thing times the outside, just like the previous one, equals this one squared. So the entire thing times the outside equals dc squared. That is the tangent secant product theorem. They start off this one with a word problem. You're going to have a word problem in your homework, so let's go ahead and go through it. It says the diameter of the Earth is 8,000 miles. This is our Earth. This is our diameter. It's 8,000 miles. A satellite is in orbit 6,400 miles above the Earth. So this is going to be 6,400 miles. Its range is shown by SP, so this is its range. We want to see how far it can reach, and we want to find out how far that is. So we're going to call this x. So using our tangent secant product theorem, we could say the entire thing times the outside. So our entire thing is 6,400 plus 8,000, which is 14,400 times the outside, which is 6,400, equals x squared. So 6,400 times 14,400, that's going to be a large number with 4 zeros. And now I just need to square root that number, which gives us 9,600. That's our distance for SP. Miles, of course. Don't forget to write your units. Okay, and let's go ahead and do this one more time. So we'll set up our last example. The entire thing times outside equals that squared. So the entire thing is 2 plus x. The outside is 2, and that equals 5 squared. So we'll distribute our 2. So we get 4 plus 2x equals 25. 2x is equal to 21. So x is equal to 10.5. In summary, let's write down what each of these theorems are. You've got the chord, which says that this one times this one equals this one times this one. We've got the secant, which says the entire thing times the outside equals the entire thing times the outside. And then we've got our secant tangent, which says the entire thing times the outside equals this one squared. In summary, that is your, I don't think I have time to give you an example, so I'm going to just go ahead and provide you your homework here at the end. And if you have any questions, make sure to tune in.